Consider this example. I have three data sets that are similar but slightly different. I want to construct a frequency distribution table for each of these data sets and each having three classes. So for this first data set, to calculate the class width, take 27, which is our maximum value, minus 8, our minimum value, and divide by 3, which is the number of classes. So I get 6.33, round that up to 7 for our class width. Now notice in these other data sets, 8 is the minimum value, 27 is the maximum value, so we should get the same class width in each case. So starting on the leftmost table for the leftmost data set, my initial class has a lower class limit of 8, which is my minimum value. Add 7 to that, and you'll get the next lower class limit, and add 7 to that, you'll get the next lower class limit. Now to calculate the first upper class limit, I look at my 15, and I say, all right, this upper class limit must be 1 less than that, 14. Now I can add 7 to each of those to get the next upper class limits, an alternate way of calculating the upper class limits. 7 being the class width. So now count up your frequencies, 8, 5, and 3 in each class is what I got. Now, this next data set is different only in that it contains decimals that go out to the tenths place. So what that means is we calculate our lower class limits in the same way. So I start at 8, add 7, I have the same lower class limits. But if my upper class limit in the second one is 14, and my next lower class limit is 15, 14.9 is not accounted for in any of the classes. So in other words, what I need this upper class limit to do is account for these decimals. So now instead of subtracting 1 from the 15 here, I'm going to subtract 0.1. And that leaves me with 14.9. So in other words, if you see a decimal anywhere in your data set that goes out to the tenths place, you need to subtract 0.1 or 1/10 to get your your upper class limit. So I can follow the same procedure, add 7 to 14.9, and I get 21.9, 28.9. And now I calculate, or I count up all the different data in each of the classes. So again, I got 8, 5, and 3. So looking at one more example, except now notice we have one data point that goes out to the hundredths place, meaning 2 decimals. So if you're guessing that to get the upper class limit here, we're going to subtract 0.01 from our second lower class limit. You're right. So my lower class limits end up being the same again, starting at 8, add 7. But now I subtract 0.01 because I have a data point that goes out to the hundredths place. So that leaves me with upper class limits of 14.99, add 7 to get 21.99, and add 7 to get 28.99. And again, add up everything in each of the classes, and you've got 8, 5, 3.